All right, this is Mr. Warwick. I'm going to take you through these notes right here for 3.2 rigid motion without coordinates. These are not the notes for 11.5. These are going to be the notes for 11.4. So the first one that you will need to write down in the notes is rotation. Rotation is where a figure is turned. It requires three things. You have to have a center of rotation. When we start doing this on the coordinate plane, it's usually around the origin 0, 0. But for now, we're just looking at rotating. We have to have a direction of rotation. We're either going to go clockwise or we're going to go counterclockwise. If you're not sure clockwise, counterclockwise, I did leave a clock up on the wall. Clockwise is from the top to the right all the way around, like the numbers go on the clock. And then counterclockwise would, of course, be the opposite direction of that. And then usually a specific angle of rotation. When we start doing these in the coordinate plane, it'll limit itself usually to 90, 180, 270 around. But when it's out there in the open, it could be anything. So just be on the lookout for those three things. Make sure you get those written down. The next thing that you have is reflection. We have a figure flipped over an axis of symmetry, so we do have the symmetry between the two figures. You can no longer simulate this reflection with your phone screen. So I'll have to see reflection maybe with a small mirror. I'll have to see if I can find some transparency things, some reflective surfaces so that we can do some reflection. Then we have translation. Translation is where you're sliding things along. It's horizontal, it's vertical, it's a combination of both. You can see this is the original figure, this is the translated figure. So you just kind of count. This one went up 1, 2, 3, 4, and went over 1, 2, 3. So that's what it would be, is we went up 4 and to the right 3, or y plus 4 and x plus 3 to get there. And then when you have rigid transformations, just the definition on rigid transformation, the shape is still the same size, the sides are still the same length, the angles are all still exactly the same, so the new shape should be congruent to the original. Your assignment today is going to be in Delta Math. So we have this level 1, this mapping without the coordinate plane. It says triangle KLM and FLG are drawn below. Use the drop-down boxes to determine a transformation that maps triangle KLM onto triangle FLG. So we have to get this one around to this one. This one, I believe, should just be a rotation. Counterclockwise is fine around point, we'll say L. So counterclockwise is going to be going back this way, and they don't give us an angle on this one. They say for lines that have the same slope. So I'm going to say this LM, this side right here, needs to line up with LG. And luckily you get to try it in this case. So I try it, I see them line up, and there it is. Okay. And then I submit, and it gives me my credit, and I move on. Ones like this, it needs to reflect. There'll be ones, this is another reflection. That's another rotation. Hopefully there'll be some translation. Yeah, translation in here. And the translation won't be any specific distance. It'll be something like where M is in the same place as U. Okay, so then we go to the level 2. And the level 2 are going to be the exact same thing. It's just going to require more than one. So we are going to rotate triangle QRS about point Q until we'll say QS has the same slope as QG, and I can try that, and I can see that they go like this. And then I'm going to reflect that new one. That's Q prime, R prime, S prime. We put these primes up there after we have a translation. And we're going to reflect that over, should be Q prime, S prime. And we try that. So there's my rotation. There's my reflection. And we got it. And it says it's good. And there we go. You can't get these wrong. So you just have to keep going until you end up in the right spot. And you can see, like, there's more than one way to do it because they rotated theirs down like this and then reflected it. And I got the same answer, just doing it a little different. So there's usually more than one way to get there. Okay. Then I put some trig problems, some word problems, so we can figure some of these things out, right? On this one, you would find the distance of this bottom side of this triangle. So it gives you this angle. So you would use trig to find this side. Then it gives you this new angle, and you use trig to find this side. And you would need to subtract this side from this whole one to find out how far it has gone. Just some extra practice, still using the trigonometry so that it doesn't completely go away for us. And there's not very many of these, so hopefully you can work your way through them. And if you have any questions on it, if you get stuck, you can, of course, ask those when I come back.